We are back in business. We have a different amplifier here just to look at now. This is kind of related to the issues I was seeing a moment ago. This amplifier is related to the issues I was seeing a moment ago with the Vibe 10K. How's my internet connection? Is it good? Yep, looking good. Cool. Okay. This is what we're working with now. So this is a Banda Viking 7000. Now this is one of the ones that I've been having a huge headache with. This is one of the ones I've been having a huge headache with. This is one of the ones that I did my previous videos where the output speaker terminals need to both have the exact same voltage on them for this thing to work properly. And I didn't have the exact same voltage on both of them, and it wasn't working properly. And I stripped it all back, and I got to the point where I noticed an issue with a couple of these capacitors here, and I replaced those, and I also found additional problems elsewhere on the board. Let's see if I can show you this. Okay, so here, right by these inductors, there are some tiny little resistors, and these have to do with sending the they feed back the voltage on the speaker terminals back to a TL072, which is being used kind of as a comparator here. Which one is it? Yeah, it's this one. And what this does is this decides what voltage the output rails should be, the output speaker terminal should be. And there was a problem with one of these resistors here, and so when I replaced that, the issue seemed to go away and the amplifier seemed to be working again. And I was like, yes, we have equal voltage on both of these. And I was like, yes, this is going to work, we're going to win. But then I put the drivers back in, and all of a sudden the thing went to shit again. But on my previous live stream, where what I just finished, I just looked at the Vibe Reaper 10K. We noticed that my solder flux seemed to be slightly conductive after it heated up. And I've got some solder flux remaining on the pads for these drivers. So, I think that this might be a fixed amplifier. We might just need to clean the board up of solder flux and replace the drivers again. So that's what we're going to do. So first of all, I'm going to remove all 4 drivers again, because one of them, like I said in the previous video, seemed to catch fire underneath it. So that's obviously not good. That's not good. So we're going to remove the drivers again and start again from where we left off before, where I thought I had pretty much fixed it. So to remove these, I'm not going to add any more flux. I'm just going to heat the legs until they come off the board. I don't know whether these drivers are any good now. They were brand new when I fitted them. But they could have now been killed by whatever was causing the short circuit to happen on the board. Still curious, can the Kenwood Acceleron run at 1 ohm? I don't know, because I'm not too familiar with that amplifier, so I'd have to look it up. I haven't come across that amplifier here in the UK. In the UK, we don't necessarily have all the same amplifiers as you guys do elsewhere in the world. Or maybe they're not as common. Maybe someone else in the chat will be able to help you out with that question. Acetone strips rosin flux quite nicely. Wicked, wicked. I shall bear that in mind, my friend. These pads have quite a high thermal mass, which means that they take a little while to desolder. I might need to turn my temperature up a little bit. Yeah, let's turn my temperature up a little bit. Let's go to 408 degrees Celsius. Holy thermal mass. There we are, finally coming up. There we go. There she is. That's number 1 removed. Does anybody else here that's watching the stream watch Hydraulic Press channel? Hydraulic Press channel? Never heard of it. Hydraulic Press channel. Or the guy, I think he's Russian. And so he says, "Welcome to Hydraulic Press channel." I can't do the accent. Apologies, that was fucking awful. "Welcome to Hydraulic Press channel. Today we are going to be crashing." What the fuck? That's one of the things he says a lot. What the fuck? And I think this is going to be good. I love the accent. I really love the accent. I love the emphasis on some of the words, like crushed. So rather than saying crushed, he says crushed. Crushed. If you were to spell that, if you were to spell the way that he says it, it would be, yeah, try and spell the way that he, in the chat, try and spell the way that he says crushed. Crushed? I think there's an L in there. CL. CLR. Crush. Crushed? I believe they're from Norway. I love his accent. Hydraulic Press channel. Koreshed, yeah, he says Koreshed. It's Finland, so next to Russia. Okay. I wasn't far off then. It's that part of the world where they swap their W's and their V's. So, W becomes V and V becomes W. Which was interesting because so my business partner, who I did the LW audio amplifiers with, so obviously I call them LW audio, but in Sweden, where they're made, where the Loris Vasterson, where he lives, they call them LV audio because W is pronounced with a V and the V is pronounced with a W. So when he was talking to me about the VAT, the VAT, he was saying, yeah, we need to look at the VAT, and I was like, the what? The what? What? But he was talking about the VAT, the VAT. And he's like, yeah, the LV audio amplifier. I'm like, the what? The what amplifiers? Oh, you mean the LW audio amplifiers. Okay. What other amp brands or audio brands have a V in the name or a W in the name? And how will they be pronounced by my good friend Lawrence Vasterson? This one's being a right bitch to come off the board. High thermal mass. And Beyond the Press channel is pretty good too. Yeah, I've seen a couple of vids from there. You've got a nice view of my arm. This driver does not want to come off. Does not want to shift. Holy crap. Oh, you're not even in view anymore. So that would be pronounced Sörenvägar. So yeah, Sörenvägar in Sweden is pronounced Sörenvägar. How many watts does it do? Why audio? Also, in Sweden, whenever anything's annoying, he's always saying, it's a shit. Like, it's a shit, like a singular shit. So, like, you know, when the exchange rate was going bad, he was like, yes, it's a shit. It's a shit. Like, a singular one. This is driving me nuts. Literally, there's so many degrees Celsius here. Why is that not lifting up? Come on. Damn it. I'm not adding any more flux either, because that shit, we've seen what happens there. This thing still is hot, isn't it? Yeah. Yeah, I'm going to turn the pressure up a little bit. It's a sheet. Money my borat. Money my borat. How many watts do you put your subwoofer in the car? Back in Kazakhstan, we have a sound system when we put 10,000 watts. Very nice, I like. About time. Jesus. Very nice. I like it. How much you repair amplifier? My cousin in Usek, he repair amplifier for $20. Very nice. Use a hairdryer to heat the whole PCB to 60 or 70 and then try and remove the IC. Yeah, that's probably not a bad idea. Because then it would, yeah. Let's just try and heat the generator a bit more. I get clock radio, he cannot afford. Great success. All-nighters again. Yeah, seems to be that way. Okay. Right, so we've removed all the drivers. Has anyone just joined me and has no fucking idea what I'm doing and why I'm doing it? Fixing an amp. I have no idea what's the fool you're doing anymore, Sammy. So should we start this? What's really funny is I haven't had a clue. I just do what my phone tells me. Toothbrush. We need to just completely coat this whole board in alcohol because this has got flux everywhere on it, and from what we've seen before, that's not a good thing. Also, this toothbrush isn't too clean either, so let's use something else. This rag has some thermal paste on it, but thermal paste is fine, just for a moment. If you're relatively new to the stream and you didn't watch the start, then this is a Banda Audio Viking 7000, and this came in with a pair of blown FETs across 2 banks. So it wasn't just one bank that died; it was one FET from each bank on one side that died. I took all the FETs out because on these amplifiers now I'm replacing all the FETs with fresh ones for various reasons. And when I took all the FETs out and I checked the drive waves, we had DC offset on the speaker output terminals, which means that one of them was a higher voltage than the other. The way this amplifier works is it's a full bridge amplifier, so you have about 70 volts DC on each of the speaker outputs, and it has to be exactly identical, otherwise you have DC offset and the speaker will pop up or get sucked in when the amplifier turns on, and it means it will blow very shortly as well if you try to use it like that. So I took all the shit apart and was trying to find out why we had DC offset, where the fault was, and it took me hours and hours and hours. Found the fault, resolved the fault, put the drivers back in, but as soon as I put the drivers back in, the fault returned in an even worse manner. So I just finished repairing a Vibe amplifier, and I noticed that for some reason my solder flux seems to go conductive at weird points. So what I'm doing now is I'm wondering whether that is what was causing my issue on here to return once I put the drivers back in, because I did use solder flux here. So I'm now cleaning the board off the hell with alcohol and a rag in an attempt to try to get this thing working again. Twice blown, 231. No, this is not the same amplifier from last night. I was working on that earlier today, earlier this evening, and we almost fixed it. We've almost got there. The amplifier comes on, but we don't have any drive, so I think we have a driver board fault or something. But in order to progress with it in a logistic manner, I need to install one of the brand new driver boards, which I can't do because I'm waiting for headers, because the pads on the board have been damaged by the owner who tried to remove the driver board and he pulled all the vias, and so I need to wait for headers to arrive so that I can install the new driver board properly. Right, so with all the drivers off of this board, yesterday when I was working on it, I got to the point where we had equal DC voltage on the two speaker terminals. So let's see if we have that now. I've cleaned it up a bit. I think I've got rid of all the solar flux and all the stuff that shouldn't be there. You need a small brush. I have a toothbrush here, but the problem is I've used it so many times to clean off carbonized areas that it probably has conductive carbon particles in it, maybe. So just to iron out that being the issue, I'm not using it at this time. I could clean it off with alcohol, and I could like clean it on the table maybe to get rid of the blackness so it goes white, and that might work. Initial Pro. In that case, if you have an amplifier that does that, then you have some vibration damage. Obviously something is making a broken connection, so you need to take that amp apart and find out where the snapped connection is inside, because you can't continue to use the amplifier like that because you risk blowing it and damaging the speakers and the amplifier. So you need to look into where that issue is and fix it. I wish I had an ultrasonic cleaner that was big enough to fit this board in. That would be fantastic. That would make my life a lot easier. But they're very expensive, and the amount of times that I need an ultrasonic cleaner is quite few. I'll tell you what would be fantastic. Like, donations were never a thing. I never did this with the intention of donations, but people have said that they want to send me donations, which is amazing. And I want to obviously put the donation money towards something useful for the channel and useful to my work. So an ultrasonic cleaner would be amazing. It would be really helpful. It would clean up all the crap on the boards, and just, you know, it's something that's not essential. So I probably wouldn't go out and buy it with just the money that I get from the repairs, because I can put that towards maybe different things in life. But yeah, with the donation money, I want to maybe expand my inventory of workshop workshop equipment, and so an ultrasonic cleaner would probably be one of the things that I would look to save up for, and I would use the donation money to get that. I know they're very expensive. Why are we talking about cereal in the live chat? What's that all about? Right, okay, let's power this board up and see whether I'm at the same stage that I was yesterday. I didn't do this on live stream yesterday. So the point where I was at yesterday is I had equal DC voltage on the two speaker outputs, which is what I need for this amplifier to work properly. And then as soon as I added the drivers, I no longer had that. So I need to try and work out what's going on here. Matt over here eating cereal. I struggle with cereal because I hate milk, so I really hate milk. So I can either have my cereal dry, right, or not at all, really. I like milking things. I like milkshakes. Milkshakes are great. Just not milk on its own, you know. Like, nah, man, not all about that milk life. That was a pretty spark. Oh, come on! I just unplugged you. You capacitor's discharging in the flipping power supply. I'm too lazy to put my bigger tip on. I should probably put my bigger tip on for this. Come on, get on there. Stay. Oh, for fuck. Fine, you win. Bigger tip. I was booted from the Steve Mead forum for saying capacitors had a future. Really? On the bottom side of the board we have rectifiers. So the rectifiers on the output side of the transformer are mounted on the bottom of these boards. Matt, I read that comment there. He runs 4 super caps as he runs 4 sugar caps, because we were talking about sugar puffs earlier. And I was thinking to myself, what the fuck is a sugar cap? Alright, so should we see where we're at then with this? Let's see what this is doing. See if this is going to behave. I haven't had much luck. I've not had much luck over the last couple of days. It would be nice when we get when we're able to do a live stream where I can fix, you know, because generally I in one sitting, in a sort of 6-hour sitting, I can fix 3 or 4 amps. But to be fair, the last few days has not been like that at all. Very frustrating. So I'm going to turn both my probes on, and we're going to turn them both to 20 volts there, so I can put my probes on both the speaker terminals to make sure and see whether they are both equal or not, because they both need to be equal for this to work. Just do a quick visual check for any solder bridges on any of the driver pads. I think we're good, because we did just remove the driver ICs, so I just want to make sure that we didn't knock over any solder. No, we didn't. Okay, so this is scary voltage, but we haven't got any rail caps, so. Oh, help if I plug the power supply in. Oh no, look, it's all over the place again. Oh man. I got to the point yesterday where this was working. Oh man. Oh, holy crap! Holy crap! Right, guys, look at the screen here and tell me if you see anything funny. Where's it gone? Is it going to do it again? Is it going to do it again? Can you see that on the screen? Something is sparking on the board. Something is sparking on the board. I wish this would focus closer. I need a macro lens or something. Okay, yep, so there is a spark on the board. There's a spark on the board. And the spark is coming from just here. Just here. I don't know why that is. So we need to see, where's that pad supposed to connect to? So we take our multimeter and we find out where that little trace is supposed to connect to, because it might be sparking because it's not connecting to something, because it's not connecting to something that it should be, or that it's connecting to something that it shouldn't be. One of the two. So that's this trace here, and that doesn't go to either of these pads. So this trace is meant to go all the way over here. It jumps over to this trace here. Okay, so why is that sparking? Let's take our Stanley blade here, and let's sort of just scratch away at that area in case there's any carbonized board or anything that's not meant to be there. It looks pretty clean though to me, like. Yeah, this trace here is ground. This big one here is ground, so something is jumping to ground through the board or through a trace or something. Yeah. I'm wondering whether these drivers have got so hot in the past that they've actually carbonized the board. If that's the case, and then this is a waste of time. What's stupid is this side was the good side. This side was the good side before. Well, it seemed to be the good side anyway. Let's see if that spark has gone away. Nope, I can hear something crackling on the board. Oh look, there's more. There's more sparks, and it's coming from underneath this Xenodiode. Okay, so we need to remove that Xenodiode and clean under the Xenodiode. Coming from under the Xenodiode. I should probably remove all these 4 Xenodiodes actually and clean under them. Because I removed the Xenodiodes when I was trying to troubleshoot where the issue was. And it's possible that there is more conductive flux or whatever the hell is causing this conductiveness. It's possible that there's more of this crap underneath some of the ICs that I was replacing before. It looks a lot darker than the rest of the board. It looks a bit darker. It's got this this dark green. Where are we? Where are we? So you can see this is another one. So you see this dark green. This is like the kind of underlayer of the board. So I think that's all right. Drop it in a bucket of brake cleaner. Yeah, maybe. Seth sends $2. Thank you very much, my buddy. What is your email or Facebook? My Facebook is facebook.com/bearvids. You're welcome to send me a message, my friend. You're welcome to send me a message. Right, it's clean under those pads. Dental picks can be helpful in scratching funk out between pads. Oh yeah, I imagine they could be actually, because they're made of wood, so they have a low chance of actually damaging the board, but they can clean the crap out. That's a useful tip. Thank you very much. Yeah, Bitcoin mining is annoying as fuck. I agree, especially when I wanted to build a new computer to live stream with. But because everything's so expensive at the moment, I'm still using my ancient LGA 775 build. LGA 775. Now that's old school. Alright, let's see if that stopped fizzing now that we've cleaned that and removed that. La, la, la. Where's our one that was fizzing? Here we are. Here it was. Right, so we made a little bit of progress. Oh, holy crap. No, we haven't. We've now got 101 volts on one of the speaker terminals and 0 on the other. Well, that's not right at all, is it? That's not right at all. But it's different now to what it was a minute ago. So each time I remove something or clean something, something changes. So the thing that did it last time was I removed a TL072 over here on this side of the board. So I'm going to remove that again and clean underneath it. I also removed these four. I don't know if you can see this here, but there's some small resistors here. There is a resistor which is marked with 104. So that is 10, what's that, 104? That's, is that a million ohms? No, hang on. My head hurts. 1, 2, 3, 4, plus 4. That's a, well, it's a fucking high value resistor anyway, 104. And that is partly responsible for setting the voltage of the speaker outputs here. So I'm going to remove all 4 of those like I did before. I removed those before. I'm going to try and get back to the point where I was at before, where I had the uniform voltage on the outputs. So let's remove number 1, and we'll test all these after we've removed them. Number 2. Number 3. Number 4. Okay. How did I learn to repair? I learned to repair by trial and error. I bought a bunch of blown amplifiers and I tried to fix them, and I learned from many mistakes, and I asked other people that I know who do amplifier repair for bits of advice here and there. Like, I'd be working on an amplifier and I'd be like, oh, does this drive wave look right? Or I'd be like, oh, I've got DC voltage here where I shouldn't have. Or, oh, I've got like I've got this part heating up, and then they say, oh, check this, check this, check this, and I'll be like, okay, check, 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 and then I'll be like, aha, that's what it was. I change it, work it out, just from trial and error mainly. I also downloaded Perry's amplifier guide, repair guide, from bca1.com. It's $40 and it's worth every cent. It's amazing. I learned a lot from that guy, from that guide. Do you still do Basso Profundo? No, because the software that I used, it broke and I didn't have the license key anymore, and so I never pursued it. I never got around to fixing the software, so I didn't do rebasses anymore, which is a shame. I loved doing the rebasses; they're wicked. I might start doing it again. I might reinstall all the software if I can be bothered. But to be fair, these days I'm technically too busy doing this kind of stuff. Camera's out of view. Sorry. Have you ever made an amp from scratch? No, but I plan to in the future. When my knowledge gets to a point that I'm happy enough, that I'm confident designing an amplifier, I will design an amplifier from scratch. And the amplifier that I design will probably be a Brazilian style amplifier, but with the reliability of a Korean amplifier, because I think that will sell well. Okay, so let's clean under that 072C. It didn't look like it was dirty. It was not a dirty part of the board, but it's responsible. It has a responsibility for part of the output rail. So we're going to clean it anyway. Clean it anyway. Dude, is that a Xenon 4 bridge? No. Alright, what's up? Professor Vids. So this guy in the live chat, Professor Vids, is Mr. Harwood from Harwood Acoustics. He's the guy that's been doing my car for me to a beautiful standard. No, my friend, this is a Banda Viking 7K with some crazy headache problems. We've had small fires on the board on this one. Small, very, very small fires. Tiny spark fires. Tiny spark fires. Right, so I've removed the TL027 and I've removed the 4 high value resistors, which are partly to do with the generation of the DC voltage on the output terminals. So we had 102 volts on one and pretty much 0 volts on the other a moment ago. So this is the point where I was at before, where I got it to pretty much work how I wanted it to. So let's see what we got now. Okay, so we're back. We're now at 95 volts on one and 0 on the other. From memory, with the 027 out of the amplifier, we shouldn't have anything on this speaker output terminal. We shouldn't have anything at all. We should just have 0 volts. So perhaps we've got a solder bridge on one of these driver pads. So the next thing that I'm going to do is I'm going to take my small tip soldering iron, and I'm going to just run my iron over all of these driver IC pads. Burning the midnight flux, eh? For sure. Last night we were up till about 5 AM and we did a 7-hour live stream on a Vibe Reaper 10K that belongs to Tom Crown, and we're nearly there with it. That amplifier, yeah, you will. I'm not going to say watch the whole live stream because it's like 7 hours long from yesterday and another 4 hours long from today, but I'm going to edit it down into one convenient, well, probably a few convenient little 20-minute videos that you can watch to find out what the fuck What happened? What happened? I love your videos from the USA, says Seth. Cheers, buddy. Thank you very much. I love your support. I love your company whilst I'm doing the daily grind. Missions, says Professor Vince. Yeah, man, fucking missions. Trust me. I say what ever since I started live streaming from the workshop, the amplifiers that I've been repairing have been pure missions. Like, literally. Although actually the solid audio wasn't too bad. I did a solid audio live stream repair. That was actually fine. Solid audio F2500, and that thing actually put out 3,100 watts RMS at 0.5 ohms. Which is pretty crazy. So the 94 volts we've got is on this side, which shouldn't be there. So we need to find out why. Why is there 94 volts on this side that should not be there? You're not welcome here, 94 volts. Go away. Go back to where you came from, 94 volts. Hardest repair he's ever done by far. Which one was that? Oh, the Vibe Reaper, yeah, definitely. That amplifier repair could have been made a lot less hard if the owner hadn't removed the driver board in the way that they did. Because by removing the driver board in the way that they did, I think it's caused far more problems than we would have imagined. One moment, let me just take a quick call. Okay, we're back. We are back. Well, I've just gone through solder bridges there, so I'm just going to power it up again one more time. What have we got in the live chat? 94 volt gets its coat. For sure, man. 94 volt can fuck right off. 94 volt can fuck right off. Right, I've just done a little bit of seeing whether we've got any solder bridges, so let's power this up again, see if that's changed anything. Probably hasn't. Nope, so now we have 98 volts and 1 volt on the other one. That's not right. So last time when I did this and I looked at this amplifier, as I mentioned earlier, we have some small resistors which are by these inductors, and these are part of the feedback circuit, and these tell the main circuit over here on the board what voltage the speaker terminals are sitting at, so that the circuit knows what voltage to give the output. So I'm going to remove those and see if the 98 volts goes away. I'm just going to check which side that's on again, because which side it's on depends which ones I remove. So it's on this side. Okay, this side. Okay, Google. Set a timer for 20 minutes. Cool. So let's get to removing those small resistors. Professor Vids, right, I've got to get to sleep. Tomorrow brings more welding. Good night all. Good night, Henry. I hope your welding goes well. See what I did there? Welding. I'm sure it will go well. Man, I'm getting hungry. We hungry. What film is that from? We hungry. Fast and Furious, yes it is. Good night all. Brazil, it is 11:30. Good night, man. Good night, my man. UK, it is 2:30 AM. Okay, feedback resistors removed. Check this again. Okay, so now we're not getting that 90 volts anymore that we were seeing a moment ago, but we are getting a slow rising voltage. So something's slowly rising, slowly rising up to 88, 90, 100 volts, 113, 115, 116. And now it's going back down again. Okay. I wonder if anything on the board is heating up. Problem is I've just been blasting the board with copious amounts of heat from the hot air station, so I might have skewed results. We hungry. So what's getting hot on the board then? We've got 50 degrees where I just was doing some hot air soldering, so that doesn't help with my findings. Let's power this up again and see if anywhere on the board is getting hot. High voltage still on this side. So we have a chip here which is sitting at 57 degrees, 60 degrees. Okay, two chips here. I wonder if I could remove those. Actually, yes. Because those two chips are mirrored on the other side, and... Yeah, I wonder whether I should just remove this chip here. Let's spray some alcohol and see whether it evaporates off the board, just as Lewis Rossman does. Let's just see whether that bit is heating up like it shouldn't be. So I'm going to spray some alcohol in this general area. Fire up. Yes, so those two chips are getting toasty roasty. That one especially is getting damn hot. Okay. So that could be a problem. Yeah, it's getting very flipping hot. Okay. And that is what chip is that? Can't actually read that, there's too much alcohol and all sorts on there. Let's rub this off a little bit. Well, it's either a 4052C or it's a... No, yeah, that's probably what it is. 4052C. And they're both 4052Cs. Let's remove those and see whether our high voltage goes away. Going on in the live chat. Bevids, where would that voltage come from? Good question. That's what we're trying to find out. Test the FETs on the board. There's no FETs on the board. There's no FETs in the output section on this board. All we've got is a power supply section, which is fine. The power supplies on these are rock solid. They never die. If I was going to ever design an amplifier, I would design a power supply section based on this. This uses IRFB 3077s, driven by 4427 international rectifier chips. Chip shorted, yeah, possibly. We're going to remove it and find out. We're going to remove it and see if our issue goes away. And I ain't adding no damn flux. I do unfortunately have to shoot off in about 15 minutes time. I need to go and pick somebody up in the car. Bye bye. I have no flux to give. Yeah, man. I have no flux to give. Not this time. I'm going to buy some of Rossman's flux. I'm going to rock with that. Okay. Just clean that area in case any flux got underneath it from any other repairs elsewhere. Just going to do a quick multimeter check to see if any capacitors or anything around the area are shorted. Seems to be fine. Dayton Dat's video. He looks at the Sony PDF for the parameters they still host. Yeah. 226. I've got about 10 minutes left of the stream before I've got to shoot off. Alright, let's power this up and try this again and see. Let's see whether we have lost our stanky 98 volts. Are you fucking kidding me? Now we've got 120. Oh man, what? It could be those though that are dead, right? So it could be what these do is that these chips could tell the whatever it is it's setting the voltage to there, whether to go high or go low or whatever. So if those were dead, then it could have been giving. But when you remove them, it could just send the full voltage to the outputs. But when they're so, oh man. Let's remove every damn IC from this board. Let's remove these two as well. Let's remove these two as well. What are these? These are something else. I don't know what they do. I don't know what they do just yet, but let's remove them anyway. I'm getting to that point now where I'm like, fuck this. Let's just remove shit from the board until the issue goes away. How about that? No, they're not part of that circuit though. What FETs on the board? Hammer knock. What FETs on the board? There are no FETs on this board. Oh, can I test FETs on the board? I was sorry, as in your amplifier. Yes, kind of, but not properly. If you have a transistor tester, you can't use that whilst they're on the board. If you have a multimeter, you can pretty much sort of test them on the board, but it's better to remove them. You can get a rough idea of whether they're dead or not by being on the board. Sometimes transistors, they die in a way that isn't obvious to a multimeter. Let's see what we've got now. I just removed something else, some other resistor that I remember removing last time. Still 123. Right, where is it coming from? Do we have... Let's try and trace it back on the board. Let's try and trace it back on the board. Will you be resuming live stream when you get back from picking someone up, Sam? Probably not. I'm probably gonna go to bed because I don't want such a late night. It's almost 3 AM here now. So I'll probably continue this one on Sunday, and so I'll continue on Sunday. We'll continue this one, and we'll also continue the Vibe Reaper. We'll get that one up and running. .7, 121.7. So we're dropping a volt from the main rail to the speaker output. So it's not a direct short, you see? The main rail is at 122.6 volts. Yeah, but the speaker output is at 121.8 volts. So we're dropping a volt. So that's useful because it means that we can see where the path of each one goes and comes from. I'm just going to check every single damn resistor and every single damn capacitor on this side. Find out what the hell's going on here. 121 volts. 121 volts. So we got some capacitors here. But that's fine. These capacitors are meant to do that. We've got a diode here with 120 volts either side of it. I know that's not the issue. So we've got 12 volts on that pin. $122 volts there on that pin, because that's the output to the drive. Ah, that one's 121. That one's 122. That's 122.1. And that is 121.7. 121.7. 122.1. So the voltage is ever so slightly higher on this one. So I think the issue is surrounding this area here, because the voltage is slightly higher in this area. 122.0. 1. Okay, what I'm going to do is I'm going to start removing these capacitors. Could a cap be leaking and letting voltage go through? Just an idea. No, there wouldn't be a capacitor that would have 120 volts on one side and 0 volts on the other side. Or like rail voltage on the other side, I don't think. Yeah, if there was, it would be a very high voltage capacitor, which none of these are. These are all very low voltage capacitors. Okay. Unfortunately, it's time that I need to go and pick up somebody. I need to shoot off. Unfortunately, I'm very sorry, guys. But this one is an interesting repair. This one's a very interesting repair because we've got some problems that we need to find. So I will pick this one back up on Sunday, along with the Vibe Reaper from earlier. I'm just going to put all these tiny components in a little bag here. And so yeah, on Sunday, I think it'll be Sunday. I'll let you guys know if you want to know when I'm going to be live. If you want to keep up to date with when I'm going to be on and what days and what times, etc., then click the subscribe button and click the bell that goes alongside the subscribe button, so you're notified when I come live. And also, like my Facebook page, facebook.com/bearvids, and I'll put up some posts on that page when I am going to be planning to go live and what amplifiers I'm going to be repairing, so you can see whether it's worth you tuning in or not, whether you want to watch the repair of that certain amplifier, or whether you know how to repair that amplifier and have better things to do with your time. So, yeah. What time do I think on Sunday? UK time, probably around about 4 or 5 p.m, maybe a bit later, maybe 8 p.m. UK time. I don't know what that is in the States and wherever you guys are. So yeah, thank you very much for tuning in and keeping me company, guys. I will see you on Sunday. Pop, pop.